that make sense?
Choose the same points every time.
You can, but it's a little bit more difficult when you do these kind of problems, okay? Because these parabolas look, like I said, they're different in that they don't. Well, you just have to look, okay? So this is parabolic functions. We can also, these are also nonlinear functions. And this is the second part. Okay, and remember, anytime you see an equation that has an exponent greater than 1 on that x value, it's going to be non-what? Linear, right? It's not going to form a straight line, okay? Now, we're not going to do any cubed right now. Okay, all the ones we have are going to have x values that are squared, okay? But when you graph those, they're always going to form some kind of a curved line, okay? So let's start with, if I gave you, let's just start with a table, okay? And you're going to see some stuff that's different than what we saw yesterday, okay? If I have this, let's say on your table, you guys remember last week when we did f of x, that's function of x, okay? So if we have a function of x equals, let's just say negative x plus 4 squared minus 2. Okay, let's say this f of x, that means it's the function of x. That's our rule. Okay, remember yesterday how we talked about you have an input and then a process and then an output, right? 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 Okay, so that's like the process part. That's the rule part, okay? So if I have a table, it's going to look a little different than what you might have seen so far, but we're still going to do this the same way. Okay, I tried to draw a straight line. That is incredibly hard. Huh? That is not a rock. That is a rectangle-ish thing. All right, so up here, we're going to have x values. Down here, we're going to have function of x. Now, what I want you to consider, the function of x is the same, essentially, as our y value when we graph it. Does that make sense? So think of the f of x as a y. Why aren't you writing this down?
Me?
Yeah. Okay. Does that make sense? So let's go ahead and plug in some numbers here. If I give you some values for x, okay, let's say that the values I gave you for x are -6, -5, -4, -3, -2.
Bless you.
Thank you. Okay, so we're going to plug these in for each x value. Now, what do we have out here? This is just this is like a negative sign, right? It's kind of like a floating negative. Does that make sense? Yeah? So what is it? What do we treat that negative sign like? Anybody know? Jackson? Kind of. You treat it like a -1. Okay? So essentially, if we were to put a 1 in here, that's what we're looking at. Does that make sense? Okay? So if we have a -1, anytime you multiply anything by -1, what does it become? What is 6 times -1? -6. What is -6 times -1? +6. It's opposite of what it is. Does that make sense? Okay? So when we have a -1 out here, we have like a floating negative. Everything that's inside here is going to be opposite. Does that make sense? So if this, I'm going to move this down here. If I plug in -6 for my x, this is -1 times -6 plus 4 to the second power. Okay? Now, looking at this process right here, and it's -2, what am I going to do first here? Order of operations tells me I have to take care of one thing before I take care of another. What am I going to do first here? The what? I'm going to get rid of these parentheses, right? -6 plus 4, what does that give me? -2. Okay? Then I have an exponent -2. I'm done with parentheses as far as an operation goes, right? So what am I going to take care of next? Exponents, okay? I'm not worried about this yet, okay? So what is -2 to the second power? What kind of 4? +4. So now I have negative 1 times 4 minus 2, right? What's negative 1 times 4? Negative 4. And negative 4 minus 2, in my head, I'm saying that's not normal subtraction. So what am I saying in my head? Copy that opposite. So negative 4 plus negative 2 would give me what? Negative 6. So this first point is going to be negative 6. Okay? Let's look at the next one. Okay? Now, should I be able to do this in my head now that I kind of understand the process of it? Okay? Negative 5 plus 4 would be what? What's negative 5 plus 4? Negative 1. What's negative 1 squared? 1, right? And negative 1 times 1 would give me what? Negative 1. And what's negative 1 minus 2? Negative 3. Okay? Now, you're going to see, you're going to think right here that you have some kind of pattern, okay? Because this is negative, this went up 1, this went up 3. So you might think that this next one is what? 0, but it's not, because this is a parabolic, because this is a quadratic function, okay? So it doesn't work that way, okay? You might think you have a pattern here, but it's not the pattern you think of, okay? So let's go ahead and plug in negative 4 here, okay? If I have negative 4, what's negative 4 plus 4? 0. What's 0 squared? 0. Now what's negative 1 times 0? And what's 0 minus 2? Negative 2. Okay, so did it go up 3? What did it go up? It went up 1, okay? So now I have a negative 3. What's negative 3 plus 4? 1, right? Well, did we already, well, we can do that. Okay, what's 1 plus 4? I'm just going to show you. I'm just going to do it down here. Okay, negative 3 plus 4 squared minus 2. So negative 1, this is 1 squared. What's 1 squared? 1. What's negative 1 times 1 minus 2? What's negative 1 times 1? And when negative 1 minus 2 is what? Negative 3. Okay, you do the last one for me. Figure out what negative 2 is going to be. We plug it in. Okay, now the ones on your worksheet are actually a little bit easier than this. But I wanted to show you one that was a little bit of a challenge. Okay, I don't care if you do this, the actual operation in your head. You should be able to. Okay, you should. I mean, if you want to write everyone out, I'm fine with that too. Okay, but I put the tables on here for you. Okay, what did we get? Anybody have an answer yet? What did we get? Tell me on 3. 1, 2, 3. Negative 6. Good. Okay, now, did you guys write this down? Let's go graph this. Okay, and let's see. This is going to look different than what we did yesterday. What's the first point I have there? Negative 6. Okay, so that means I go back 6 and where?
Down.
Okay, what's my next point? Look at your graph. Look at your table. Negative 5, negative 3. So back 5, down 3. What's my next one?
Negative 4, negative 2.
Negative 4. So back 4, down 2. What's my next one? Back 3, down 3. What's my next one? Back 2, down 6. Okay? Did we still form a parabola? Yes, but it is not. The pointy part, okay, is not on the y-axis. Okay, does that make sense what we did? Okay, and all we really have to do now is put our line in there. Okay, all of your answers, every single one that you graph today, is going to look similar to this. Okay, matter of fact, I don't think any of them are. No, there's a couple that are exactly on the y-axis. There's even some that are exactly on the x-axis. Okay, but all you've got to do is plug in those points. Okay, 9 problems. But I already gave you the tables. Okay, all right. Should we do another one, or are we good to go on this? Tell you what I'll do. I'll pass out your worksheets, and we'll do the first one together. Fair enough? Okay. No. What? No, wait. You have partners? We have until
8:25.
No. Then you go to chapel after C period.
What?
Oh. I'd rather. I'd rather.
Yes. I don't disagree with you, but these other pinheads that can't work together in partners, because they just goof off. And they ruin it for all you really good kids. I'm sorry. You're welcome. Yeah. All right. Oops, sorry. Okay, everybody look at the first one, okay? I'm going to write the table up here. Now, all of your graphs, okay, your graphs are moved around in such a fashion that you should be able to fit all of your points on your graph. If none of your points on your table, when you complete the tables, none of your points are going to be off your graph. If you do complete those tables and they're off the graph, you did something incorrect, okay? Does that make sense? All right, so let's take a look. Let's take a look at number one, okay? Let's do our table here. Thank you. Here's the worksheet. Okay, let's look at number one. All right, my f of x. What did I tell you guys to think of the function of x as?
Y.
That's like your y value. Okay, equals x squared minus 6x plus 11. Now, when I replace x, how many x's are up there? There's 2 x's, so you're going to have to replace both of them. Okay, do you think that changes anything else? No, we're doing it the same exact way. Okay, so our table. Yeah, that's a.
It was almost.
No, I don't want it. That's a perfect box. Don't mess with me. Okay, so we have our first value is 1. We're going to go 1, 2, 3, 4, 5. Okay. So when we replace this x with a 1, okay, you think we can do this in our heads?
Yeah.
I think we probably can. Okay. What is 1 squared? 1. Okay. Minus, what's 6 times 1?
6.
What's 1 minus 6?
-5.
Negative 5. What's negative 5 plus 11?
6.
6. Okay, did we do that in our head?
Yeah.
Yeah. Again, if you want to write it out, I'm 100% okay with that. Okay? All right, let's look at the next one. What are we going to replace x with? 2. What's 2 squared? 4. Minus, what's 6 times 2? 12. What's 4 minus 12? Negative 8. What's negative 8 plus 11? 3. Do the next one. Do it on your own. Let's see if we can figure it out.
2.
You guys agree? Or are you just saying that because you want to be done? What is 3 squared? 9. 9 minus 6 times 3. 9 minus 18 is what?
9.
Negative 9 plus 11? 2. Okay. 4 squared. What's 4 squared? 16. Minus, what's 6 times 4?
24.
What's 16 minus 24?
8.
What? Negative 8. Negative 8 plus 3? Negative 8 plus 11? 3. Sorry. Okay, and the next one. 5. What's 5 squared?
25.
25. Minus, what's 6 times 5?
30.
What's negative? What's 25 minus 30? Negative 5 plus 11?
6.
6. Are we done?
Yes.
Okay, let's graph these. Let's graph these and see if we did it right. Okay, our first one is over 1 up 6 right here. Our next one is over 2 up 3. Our next one is over 3 up 2. Our next one is over 4. Okay, I goofed that up, sorry. Over 3 up 2. Our next one is over 4 up 3. And then over 5
6.
up 6. Okay, is this what we have? Is this what we have? So we're going to put our line. Okay, that's what number 1 should look like. Does that make sense? Yes, sir.
So don't the first two equal what's on the other side because they have to like.
They do.
So once you get the first 3, you can just count.
You can, yes, you can.
Yeah.
Figured it out. Good job. All right. Okay. Let's get her done. Chop, chop. By the way, look at number 2. What is number 2 very similar to?
The one that we did as
The example that I showed you where you have a negative just sitting there outside of the parenthesis. What do you treat that like? -1. Okay, go.